video number 2 for section 2.5. We're going to continue looking at some applications of our quadratic functions, okay? And for this particular video, when we get to our second example, you're going to need your graphing calculator because we're going to be modeling a data set with a quadratic function, okay? So we're looking at examples 3 and 4 today from your notes. In example 3, we have a farmer that has 2,000 yards of fencing to enclose a rectangular field, okay? And he can play around with the dimensions of the field in order to try to come up with a particular area, right? So the first thing we want to do in part A is express the area of the field as a function of the width x of the field, okay? So if here's your rectangular field, we're saying that the width is x, and then we'll call the length y. That means area of this field is x times y, right? But notice the wording here. We want the area expressed solely as a function of the width x, okay? Solely in terms of x. So that means your y has to be rewritten in terms of x, okay? And that's where the 2,000 yards of fencing comes into play. Understand this 2,000 yards of fencing represents perimeter of the field, okay? So while we're expressing area, we first have to look at perimeter based on our givens, okay? So I'm going to take my perimeter formula for this rectangle, 2x plus 2y, and I'm going to set it equal to 2,000. Because I want to use all 2,000 yards of the fencing, all right? And then I'll solve that for y. So that means the length of the field is always equal to 1,000 minus the width of the field when your perimeter is 2,000 total yards, okay? So now I can take this expression, 1,000 minus x, and I can substitute it in for y in my area formula. And it'll give me the area expressed solely in terms of a function of x now. And notice what type of function it is. It is a quadratic function. A of x equals 1,000x minus x squared. That's a quadratic function where your a value is -1, your b value is 1,000, and your c value is 0, okay? Here would be kind of a simplistic graph to go along with that function. So when you start out, if you have a really small width, you're not going to get a very large area. As you increase the width of the field, you'll start to increase the area of the field, but then only to a certain extent. Once you start to make the width too large in comparison to the length, then your area is going to start to decrease again, okay? So what are the dimensions of the rectangle that encloses the most area? Basically, we're trying to find the vertex of the associated parabola for this function. So I'll start by getting the x-coordinate using negative b over 2a, negative 1,000 divided by 2 times -1. That simplifies to 500 yards. I need the width to be 500 yards. Plug 500 back in right here to get the length. 1,000 minus 500 gives me a length of 500 yards as well. So really, to maximize my area, I'm going to need a square, not a rectangle, a 500 yard by 500 yard square, okay? Now part C, what's the largest area of the fencing that the fencing will enclose? You'll simply just take your 500 by 500, multiply it out, 250,000 square yards, okay? Now this is just one very simplistic example. Understand we used a rectangle in this example, but we could be doing this really with any shape. You know, we could do a triangular field, we could do a circular field, lots of different ways we could spin this problem. And you just think about the different formulas that you would be utilizing based on the shape of the shape that you're trying to find the area for, okay? All right, second example, example 4, here's where we are now given a data set that can be modeled with a quadratic function, okay? We have a farmer who's collected data showing crop yield Y in bushels for various amounts X of fertilizer used in pounds per 100 square foot. All right, so you can kind of scan the data here, and you can on inspection see that there's kind of a quadratic model that's playing out. So it starts as you have very little fertilizer, you don't have much crop yield, but as your fertilizer starts to increase, so does your crop yield, right? But only to a certain extent. If you put too much fertilizer on, then your crop yield starts to decline a little bit towards the end. So this would be a nice little rough sketch of this particular situation, right? Just a little bit of fertilizer yields just a little bit of crop. As you increase the fertilizer up to a certain extent, you get more crop, and then too much fertilizer starts to hurt your crop yield, okay? So what we can do is we can model this with a quadratic function. We can put this into our calculator, much the same way we did when we were trying to come up with linear models. I've already done this just to make the video go a little quicker. To input this in, recall you just have to go to Stat and Edit. You want to put your data into List 1 and List 2. Once they're in List 1 and List 2, you'll go back to the Stat button. You'll go over to Calculate. And this time we want option 5, which is for quadratic regression. We're choosing that because we're noticing the data has a quadratic trend to it. When I select option 5, it takes me to here. I want to tell the calculator to store the regression equation into y sub 1. So recall that's just variables, y variables, function, y sub 1. Then we hit calculate and enter. All right, so it comes up with my quadratic parameters in standard form. So the A value should be this number, B value this number, C value this number. And then it also gives you an R squared value. We don't really care about that for now. So this would be the quadratic model rounded to 3 decimal places, okay? If you go to your y equals menu, your equation should be stored in for y sub 1. And then before you hit graph, do a zoom 9 so that the window gets adjusted around your point. So there's your scatter plot along with the equation graphed, okay? Now in part B, we can use our equation to determine optimal amount of fertilizer to apply and how much crop yield we would get with that amount of fertilizer. So we're talking about the vertex of the associated function. So I'll start with negative b over 2a. That yields just over 31.5 pounds per 100 square feet of fertilizer. Plug that number into my function for x, and that'll give you your crop yield. So just under 21 bushels is the maximum amount of crop yield I can expect for this particular data set. Okay, that's all we got.